Hello and welcome to my podcast. Today's topic is food security. More specifically, we're going to dive into genetic crop selection and how this scientific innovation could help cultivate food in places with harsh environmental conditions. For this, I have the pleasure of interviewing Isabella Roche, a Kenyan college student majoring in biology. Isabella, it's a pleasure having you here today.
Hi, I'm happy to be here. I'm currently a junior studying biology at Kenyan College.
Fascinating. Okay, so Isabella, why is this topic important today?
So, genetically modified crops have many benefits that can help improve sustainability in agriculture.
That's a great point, Isabella. And it's especially relevant for regions like Ecuador and much of Latin America, where agriculture is both a cultural foundation and a key part of the economy. Many communities here face challenges such as unpredictable rainfall, prolonged droughts, soil degradation, and the increasing impacts of climate change. These conditions directly affect crops like maize, potatoes, quinoa, and bananas, foods that millions depend on every day. So, to dive right in, let's set what problem do farmers face in harsh areas.
The farmers can face many problems such as droughts, extreme cold and hot temperatures, poor soil quality, and limited resources.
So how do these conditions influence food production?
Extreme temperatures and droughts can cause crop stress. When there's this crop stress, it can lead to reduced yields, lower crop quality, and crop failure.
I understand. So how can science help solve these issues?
When science is used to genetically modify crops, it can improve the crop's tolerance to environmental stress and increase yield production.
So, to understand better the science behind this, can you tell us what exactly is genetically modifying a crop?
So, genetic crop modification is used to create a plant with desirable traits by making changes to its DNA. To do this, scientists determine what trait they want and find an organism that naturally has this trait. Once they have the organism's DNA, they isolate the gene and copy it many times. The gene is then inserted into the DNA of the plant cells, and the plant cells are grown into a mature plant that carries the new trait.
Amazing! So, how is this any different from traditional breeding?
So in traditional breeding, there's a limit because the genes must come from a same or similar species so that they can be sexually compatible. But in genetically modified crops, the genes can come from any organism, which allows for traits that aren't possible through natural breeding.
I understand. So, can you give us any example of a modified crop?
Yeah, so a popular modified crop is corn. It's modified to have a trait for insect resistance, which reduces the need for chemical insecticides. Other genetically modified crops are apples, potatoes, and soybeans. These crops are genetically modified for herbicide tolerance, disease resistance, and maintaining visual appeal.
Wow! So, what benefits and consequences do these crops bring?
The benefits are that genetic modification can increase yield production, enhance nutrition, improve disease resistance, improve tolerance to environmental stress, and decrease the use of pesticides and insecticides. Some downsides of genetic modification are that it can affect other organisms around the modified crop, negatively impact microbial diversity, and there are potential allergens that can put at risk human health.
That's a great point, Isabella. And in places like Ecuador and Latin America, these benefits could be especially impactful. Higher yields and stress-tolerant crops could help farmers cope with extreme weather, new pests, and climate conditions that are already impacting the production of crops like maize, potatoes, and bananas. But the concerns you mentioned are also important here. This region has a rich biodiversity, so genetically modified crops could impact native species or soil microorganisms. There's also a social issue. Many small farmers worry about becoming dependent on patented seeds and losing traditional farming practices. Overall, generic crop technologies offer real opportunities for food security, but they also come with environmental and cultural risks we need to manage carefully. So, to highlight this, let's talk about the impacts and the ethics. Are there any risks or downsides speaking in a social context?
Yeah, so there's the risk of certain communities or cultures having a moral issue with genetic modification because it's unnatural, and they believe something that's unnatural shouldn't be used.
So, talking from the Ecuador's point of view, that makes a lot of sense. And in the social context of Ecuador, these concerns run even deeper. Agriculture here is closely tied to cultural identity, especially with indigenous and rural communities who have preserved traditional farming methods for generations. So when a technology like genetic modification enters the picture, it's not just a scientific issue, it can feel like a disruption to ancestral practices and the relationship people have with their land. There's also the question of power. Many genetically modified seeds are owned by large corporations, which means small farmers could become dependent on buying seeds each season instead of saving their own. In a country where so many families rely on small-scale agriculture, that could widen social and economic inequalities. So socially, the risk isn't only about whether the crops are natural or not. It's about who benefits, who loses control, and how new technologies might reshape communities that have deep historical and cultural ties to their environment. So, how can we make this technology safe and fair?
Safety-wise, we need to ensure that there isn't any gene flow from the modified crops to wild ones, and that modified crops meet food safety regulations. To ensure fairness, we need to lower licensing fees so that small farmers in developing countries can afford genetically modified seeds.
So, looking into the future, what would you say is the future of farming with genetics?
In the future, genetic modification of crops will likely increase and focus on traits that will help agriculture cope with climate change.
So, in the end, genetic crop selection isn't just a scientific breakthrough, it's a tool that could redefine food security in regions facing harsh climates like Ecuador and much of Latin America. The potential is enormous, but it's the responsibility. If we balance innovation with environmental and cultural care, these technologies could help us build a more resilient and sustainable future for everyone.
I completely agree. Genetic crop selection has incredible potential, especially for regions facing tough environmental changes. But it's not just about creating stronger crops, it's about using this technology responsibly, protecting local ecosystems, and supporting the communities who depend on agriculture. If we approach it thoughtfully, genetics can become a powerful tool to strengthen food security and help build a more sustainable future for countries like Ecuador and across Latin America.
Thank you so much, Isabella, for your input.
Thank you for having me.
And thank you for listening.